Right, this is attempt 37, RPA osmosis. You should know what osmosis is. I've made a video on it before, a very boring one. But if you can't remember, I can bore you again. It's the movement of water from a high concentration of water to a low concentration through a partially permeable membrane. In a nutshell, it's water going from lots to less through a membrane, and a membrane acts kind of like a bouncer, where if you're a large molecule, say you're a sugar, you can't get in or out of the cell, the bouncer sends you packing. However, if you're a smaller molecule, maybe you're a molecule, say, of water, the bouncer loves it. He's going to have a great night, in he goes, have a good one. So here's osmosis as a diagram for you. You can see I've got water, I've got sugar, and I've got that dashed line representing the partially permeable membrane. I have a higher concentration of water on the left and a low concentration of water on the right. So because of osmosis, the water molecules are going to move to the low concentration. So that's all osmosis is. Let's have a look at the actual experiment. We're going to investigate the effect of a range of concentrations of salt or sugar. We'll use sugar, I prefer saying it, on the mass of plant tissue. We'll use our trusty favourite, the potato. You could, though, use a courgette, celery, cucumber, carrot, and I can't think of any other vegetables, but anything would do, but potatoes are easy to get a hold of. Right, so step number one is you use a cork borer to give you a little cylinder of delicious potato. So you have 5 cylinders. Then I'm going to cut them all to equal length. I might dry them off, and I'm going to measure the mass using something called a top balance. So now I've got 5 pretty similar, as close as I can get them to identical pieces of potato. Now I'm going to measure 10 milliliters of 4 different sugar concentrations out. So it's the same volume, but they're of different concentrations of sugar. The highest concentration is on the right, and it gets gradually less towards the left. And finally, I'm going to get just pure water, 10 milliliters again. So now I've got different sugar concentrations in these beakers, and I'm going to put my potato in there, and I'm going to wait for a while, let's say around half an hour. So I wait, half an hour comes round, and I can't wait to see my potatoes again. Here they come. I remove them from the solution. I dry them off because I don't want to be knowing the mass of the potato and the water on the surface. So I get rid of that water on the surface. And then once again, I use a top balance to find the mass. So all I've done is I've got some identical bits of potato. I found the mass of them. I put them in different solutions of different concentrations of sugar for the same amount of time, take them out, and I've found the mass again. So I've changed the sugar concentrations, I've measured the change in mass, and I've kept, for example, the size of the potato or how long they were in the solutions or the volume of the solutions, the concentrations. I've kept them all the same. So let's have a look at the results. So here are my different beakers. I've got the highest concentration of sugar on the left, getting gradually less until I've got just distilled water on the right. And here's what I found. In the highest concentration of sugar, it lost the most mass. It lost 2.5 grams. In the second highest sugar concentration, it lost 2 grams. The third highest sugar concentration, it lost 1.4. The fourth highest, it lost 0.8 grams. And in the distilled water, it actually gained mass. You can see I'm looking all chunky over there, chunky potato on the right-hand side. So there are 2 general things here. The higher the sugar concentration, the more mass it's likely to lose. And the lower the sugar concentration, the less mass it's likely to lose, if any at all. Alright, so why is that? Let's come back to osmosis for a second. Water will move from where there's lots to less, a high water concentration to a low water concentration. So here, I've got a high water concentration in my potato compared to my strongest and highest sugar concentration. So as a result, the water will leave the potato and go into the beaker, and because water has left the potato, it's going to lose mass. Now here's another one. Once again, there's a higher concentration of water in the potato than there is the beaker, but the difference is not quite as much. So water still leaves the potato, only less now than in the previous example. So this potato will still lose mass, however it will lose slightly less than it did when we had an even higher concentration of sugar. And now finally, if we come to our water, there's actually more water, there's a higher water concentration in the beaker than the potato. So now the water is going to move into the potato via osmosis from the beaker, And as a result, that potato's taking on mass, it's gaining water, so it's going to have a higher overall mass. Now this is a bit of a weirder one you might see. If you look carefully, you'll see there's the same water concentration in the potato and the beaker. So that potato won't lose or gain any mass, because overall the movement of water is about equal. So if you see a potato that doesn't gain mass, it's because it's got the same concentration in the beaker as the potato. So hopefully now you could describe the method, you could say a little bit about the variables, you might know what the results look like, you could explain the results, and you've developed a real passion for potatoes. See you later.